Hello everyone, welcome back to my channel All4Chem. Today in this video I am going to talk about an important topic in chemical bonding, that is lattice energy. In the previous video I have talked about ionic bond and ionic compounds. In that video I have just mentioned about lattice energy, which is the main factor that affects the formation of ionic compound. If you did not watch that video, please watch it. I will give the link to that video in the description box. So without further delay, let's begin. What is meant by lattice energy? It is the energy associated with ionic compounds. Sometimes you have seen lattice energy is given as a positive value and sometimes it is given as a negative value. So you can consider lattice energy in two different scenarios. The first scenario is the formation of 1 mole of ionic compound from respective gaseous ions. Let me take the formation of sodium chloride from its gaseous ions Na plus and Cl minus ions. So in this case, when sodium chloride is formed from its gaseous ions, 786 kilojoule per mole of energy is released. As the energy is released, it is an exothermic reaction. So the energy released here is called as lattice energy, and lattice energy will be a negative sign as it is an exothermic reaction. Thereby, we can define lattice energy in this scenario as lattice energy is the energy released when 1 mole of ionic compound is formed from its gaseous ions. The second scenario is the separation of 1 mole of ionic compound to corresponding gaseous ions. Let me take same compounds, that is sodium chloride crystal. So if you want to separate sodium chloride crystal to its corresponding gaseous ions, that is Na plus and Cl minus ions, some amount of energy should be given. That is 786 kilojoule per mole of energy should be given to this reaction. Then only NaCl can be separated into Na plus and Cl minus ion. So as the energy is absorbed here, it is an endothermic reaction, and the energy absorbed is called as lattice energy and its value will be positive. Thereby, here we can define lattice energy as the energy required to separate 1 mole of ionic compound to corresponding gaseous ions. Now let us see what are the factors upon which lattice energy depends on. The first factor is the charge on the ion. Higher the charge on the ions, greater is the force of attraction and hence lattice energy will be high. The second factor is size of the ion. Smaller the size of the ions, greater is the force of attraction and hence lattice energy will be high. Let us see how these factors affect the lattice energy using some examples. Here, the lattice energies of the ionic compounds of alkali and alkaline earth metals are given. Here, the metals taken are sodium and magnesium. Let us first consider the size and charge of cations. So, out of these two cations, Na plus and Mg2 plus ions, magnesium has higher charge, that is 2 positive charge. And if we consider the size of these ions, sodium is bigger in size. Why sodium ion is bigger in size? Let me explain that. From this table, it is clear that sodium ion has 11 nuclear charge and magnesium ion has 12 nuclear charge. and these two species are isoelectronic with 10 electrons. So the effective nuclear charge of magnesium ion is higher, and so its ionic radius will be less compared to that of sodium ion. That is why sodium ion is bigger in size compared to magnesium ion. So we can conclude that magnesium ion has higher charge and smaller size. So the lattice energies of its ionic compounds are higher that of sodium compounds. Now let us consider these anions. Here the charge of these anions are same, so here only the size matters, and if we consider the size of these two ions, chloride ion is bigger in size. So the lattice energy of these compounds will be less compared to that of fluorides. Okay. So we can arrange the lattice energies of these compounds like this. Sodium chloride has least lattice energy. Then comes sodium fluoride. Then comes magnesium chloride, and the highest lattice energy is for magnesium fluoride. You can see one more table here. That is lattice energies of alkali metal halides. So if we compare the lattice energies of these compounds, it is clear that lithium fluoride has higher lattice energy and cesium iodide has the least lattice energy. What is the reason behind that? So if we compare the size of these cations, lithium is the smallest one. And if we consider the size of these anions, fluoride ion is the smallest one. So the force of attraction between lithium ion and fluoride ion is greater, and so its lattice energy will be the highest one. And here the cesium ion is the biggest in this group, and iodide ion is the biggest among these anions. So the force of attraction between cesium ion and iodide ion will be the least one. So the lattice energy of this compound will be the least value. So in this video, we have studied the two definitions of lattice energy and the factors affecting lattice energy.